Hi guys, today we're going to talk about the commutative property, and the I can statement we're working on is I can identify when two expressions are equivalent. Let's look at the commutative property. Commute means travel, so the numbers will travel or move when we're using the commutative property. Think of Jacob, who has a 10-minute commute to school. This means that he will travel or move from his house to school. The commutative property works with addition. Look at the problem 3 plus 4. 3 plus 4 equals 7. When I add it in a different order, 4 plus 3, I still get 7. The commutative property also works with multiplication. 7 times 8 is 56. But if I flip those numbers, 8 times 7 also equals 56. Before we start talking about the commutative property and how that works, let's think about some easy-to-add numbers. Numbers that add up to a multiple of 10, such as 10, 20, 30, 40, 50, and so on, make adding easier. Watch as Peg and Cat sing a song about all the ways they can make 10.
We'll have lunch with Diet and others, but right now we can have a great time walking home with our 10 friends. 9 and 1, we can skip and run. 8 and 2, we can hide and peekaboo. 7 and 3, we can pull to a bend. However you arrange us, we're still 10 friends. 6 and 4, we can skip on the floor. 5 and 5, we could race to that beehive. 3 and 7, we can rest on our ends. However you arrange us, we're still 10 friends. If 8 of us read and 2 of us count, we all add up to the same amount. If 6 of us march and 4 of us yodel, we all add up to the same grand total.
10?
1 and 9, we could shake it just fine. 2 and 8, we could rock out just great. In any combination till our celebration ends. However you arrange us,
You're never gonna change us.
And you very nice giants.
Now, in your summary, name some ways to make 10. Here's an example. 9 plus 1, or 1 plus 9. In the work section of your WSQ, list all the ways you can think of to make 10. Pause the video if you need to complete your list. So why is this useful? Well, the commutative property allows us to rearrange numbers in an addition problem so we can add them easily in our heads. Here's an example. If I had the problem 2 plus 4 plus 8, using the order of operations, I would have to add 2 plus 4 to get 6. And then take that 6 and add 8. Now 6 plus 8 I know is 14, but that's a problem that I might have to stop and think about a little longer. If I rearrange this problem, though, so that it looked like 2 plus 8 plus 4, using the order of operations, I would add 2 plus 8 to get 10, and 10 plus 4 equals 14. Both problems gave me 14, but the second one made it a little easier to add it in my head. Now it's your turn. Rewrite the following expressions using the commutative property to make it easier to add them in your head. Write questions 1, 2, and 3 in the work section of your WSQs. Then rewrite each of these expressions using the commutative property so it'd be easier to do it in your head. You can pause the video now to complete 1, 2, and 3 in the work section of your WSQ. But when you're done, press play again. So you might be asking yourself now, how does the commutative property help us multiply numbers mentally? Well, the commutative property of multiplication works the same way as the commutative property of addition. First, you must look for numbers that multiply to make multiples of 10, like 10, 20, 30, 40, 50, and so on, to make mental multiplication easier. Here are some examples. 5 times 4 equals 20. 20 is a multiple of 10. 25 times 4 equals 100. 100 is a multiple of 10. And 50 times 4 equals 200. And 200 is a multiple of 10. Let's look at some multiplication problems using multiples of 10. What do you notice about your product when you multiply a number by a multiple of 10, such as 3 times 10 equals 30, 4 times 10 equals 40, and so on? If you're stuck, here's a hint. Now, pause the video and in your WSQ, in the summary portion, explain or answer this question. What do you notice about your product when you multiply a number by a multiple of 10? When you're done writing in your WSQ, press play again. So why is this useful? Well, the commutative property allows us to rearrange numbers in a multiplication problem so we can multiply them easily in our head. Let's look at an example. 5 times 3 times 6. Using the order of operations, I would have to multiply 5 times 3 first to get 15, and then multiply 15 by 6. Now, I might not know what 15 times 6 is, so I might have to use some scratch work. But either way, I would figure out that 15 times 6 equals 90. Now let's rearrange these numbers using the commutative property and see if we can find an easier way to solve this problem. Let's rearrange it so that it looks like 5 times 6 times 3. Using the order of operations, I have to first multiply 5 times 6, and that gives me 30. Then I would multiply 30 by 3. Now, 30 is a multiple of 10, so that means it has a 0 at the end. So when I'm multiplying 30 times 3, I really just need to think, what's 3 times 3? And I know very easily in my head that 3 times 3 equals 9. And since 30 has a 0 at the end, I know I need to put a 0 after my 9, so that 30 times 3 equals 90. Notice, both expressions gave me an answer of 90, or a product of 90. However, the second expression I was able to do in my head without scratch work. Now it's your turn. Rewrite the following expressions using the commutative property to make it easier to multiply them in your head. Put numbers 5, 6, and 7 in the work section of your WSQ. Then rewrite each expression using the commutative property so that these problems would be very easy to multiply in your head. We are done with the lesson now, so pause the video and complete 5, 6, and 7. Then, don't forget to WSQ. S, make sure you have a complete summary, and Q, write a question that you have about the commutative property or a question that someone else might have about the commutative property.